Section 5 of Chapter 7, Apply Properties of Logs. This is actually really an easy, simple lesson. So here we go. Let's just ready to relax. You've got to first know what the properties of the logs are. And properties means how we can use them, how they work. So I've got three listed, the product, the quotient, and the power properties. So the log base of m times n, if you've got a log of two numbers multiplied together, you can split them up and say the log of one of them plus the log of the other. All right, so that's one thing. You may want to put this into your notes so that you remember these. All right, if you've got the log of two numbers divided, you can take the log of the numerator and subtract the log of the denominator. Okay, and if you've got log of a number raised to a power, then what you can do is you can bring that power out and multiply the power. It becomes the coefficient of the log of your number. All right, so let's put those into practice. Yes, let's use those. And the more you use them, the more you'll recognize, oh, I get it, I see. So here we go. So the first type of problem that we're going to do is I'm going to give you values for certain logs. So the log base 4 of 3 is approximately 0.792. Log base 4 of 7 is approximately, whoops, that didn't say approximately, that's 1.404. So if I want to know, well, what is the log base 4 of 3/7? What I can do is take the log base 4 of 3, and now remember this is using the property, this division property. So I'm going to subtract them. So log of 3 minus log base 4 of 7. You see where I got that? So the log of 3 minus the log of 7. And so then I know the log of 3 is this. And I know the log of 7 is. And so now I simply subtract those amounts. And I've already done it on my cute handy dandy little calculator. So the log of all of this is approximately equal to negative 0.612. And you're done. Okay? Same type of thing here. The log base 4 of 21. Well, we don't know the log of 21, but we know the log of 3 and the log of 7. And I happen to know that 21 is 3 times 7. And so remember, if we multiply two numbers, we can add their logs. So this would be the same as log of 3 plus log of 7. And so log of 3 is this, plus log of 7 is that. And so now when I add it together, I get 2.196. Oop, and it's approximately equal to, not exactly, because we did round those numbers. So far, so good. If you think you got it, work on this one, pause it and see if you can do it. And I'll go on and I'll show you. All right, so the ones we know are the log of 3 and the log of 7, but now I have the log of 49. Well, I can do that because I know that 49 is 7 squared, right? And we have a property for that. If we've got a log of a number squared or to a power, we're going to pull that power out and make that the coefficient. So the squared becomes 2 times the log of 7. Alrighty, does that make sense? So this now is the log of 7 squared, and I pulled this 2 out here because of this property allowing me to do that. So now I just take 2 times, well, the log of 7 is 1.404, and there again, this is approximately equal to, so when I multiply that out, I get 2.808, and that's it. That's all you do. Okay? Now let's take some, we're not going to get values on this type of problem. I just want you to be able to expand these logs. So this is kind of like, if you've got something like this, where do we get the parts and pieces? Where do we get the pieces that we can work with? So that's what we're going to do here. So first we look to see, well, I can divide this up and I can say that this is, first I see, ooh, it's a division problem. So it's going to be log of 3x squared minus log of 5y cubed. Do you see where I got that step? So log of the numerator minus the log of the denominator. Okay? Now I look even further and see, well, can I expand that even further? Well, actually, this is 3 times x squared. So I can divide this up into log of 3 plus log of x squared. See where I got that? Because this is a product of 3 times x squared. So I'm going to expand it and make it log of 3 plus the log of the x squared. Now we're going to subtract here. And now this is, when you've got negatives, always negatives mess us up. You got to be careful. Watch them. They're nasty. Okay, so we've got, this is also log of 5 and log of y minus 3. So now we have minus log of 5. And now here's what happens. It's all of this subtracted. So it's like this, minus all of the log 7 of 5 plus log of y cubed. So far we're doing okay? All right. So now what I'm going to do is I'm going to take these out of the parentheses, and simply because of space, I'm not going to write another whole line. I'm going to show you what I'm doing. I'm going to take these out of parentheses, and when I do that, that means everything within the parentheses is going to be the opposite sign. So this now is negative, and now this is negative, because that negative has to go through everything that it's multiplying, or everything that it's subtracting, the whole thing. So both of these are subtracted. All right. One more step, because now we do have some exponents. And so we can use that last property and get those out of there. So the log of 3 stays the same. But this one has an exponent, so you're going to pull the exponent out and say 2 times the log of x. This stays the same. There's no exponents, and there's nothing that, there's no product here. Log of 5. And now this one, the exponent becomes the coefficient. And now you're finally finished. Whew! That's a big long one. And that's the whole point. We're trying to expand those to see how we can pull those apart, pull those different pieces apart. Now, the same type of thing, if they give you the expanded version, you have to be able to go backwards and now put it back into the non-expanded version. All right. So what we're going to do here is, and this is just showing you that natural logs work the same as the common logs. All right. So natural log of 8 plus 2 log of 5 minus log of 10. So what we can do is, and I'm going to do it step by step by step here. If you can see more than one step at a time, as long as you don't skip steps, that's okay too. All right, so what I'm going to do first is, this is log of 8 plus log of 5 squared minus log of 10. Because this is the exponent, so it's 5 squared. Now, these are added, and so they're multiplied. So 8 times 5 squared. And this is subtracted, so it becomes divided by 10. And the reason I didn't multiply that all, oh, you know what? Looky here. Where did that 5 come from, Mrs. Horning? This, I totally messed that up. This should be a 2. All right. So now what you can do is you can reduce. So this is 2 times 4. And this is 2 times 5, so now those 2's will cancel, and these 5's will cancel. This 5 squared is 5 times 5, so now we'll just have 1 5, and that will cancel. So now what we have left is natural log of 4 times 5, which is 20. Okay, so this really is just reducing the fraction. So if you didn't get that, then just stop and slow down, because you should be able to get that. You're in Algebra 2. By now you should be able to reduce a fraction. All right. So if you still don't get that, make sure to come see me in class and say, where did all those numbers go? It's just a matter of reducing. All right. The next thing is we've got all these crazy bases, base 4, base 7. So there are times when we've got all these different bases and we don't want them. We want The base 10 and the base e are the ones that we want to use. And there is a formula that will allow us to do that. And that is the change of base formula. You're going to want to write this down into your notes. The log base c of a is the same as log of a divided by log of c. So log of your log divided by log of your base. And the same thing will work with base e. So log base c of a is the same as natural log of a divided by natural log of c. And that's just a matter of if you can remember that, then you can change any log. So if we've got, let's show you, let's do a couple. Let's do log base 6 of 24. I want to change it first into common log and then into natural log. All right? And what you'll do is this. So you're going to use your formula and you're going to say, well, this now becomes log base 10 of 24 divided by log base 10 of 6. And then, easy, 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 sneezy, all you'll do is use your calculator. And hit your calculator if you've got just a calculator on your phone. You're going to have to put in the 24 and then log. If you've got a scientific calculator, you've probably figured out by now, hit the log button first and then 24. So log 24 is approximately equal to 1.3802. And then you put this into your calculator. Log of 6 comes out 0.7782 when you round it. And when you actually divide that out, your final answer becomes 1.774. And that's all you do on those. You do the natural log exactly the same way. It'll just be natural log of 24 divided by natural log of 6, and then go to your calculator and find the numbers. The natural log of 24 I found on my, actually you try to do it, you pause it and do it real quick. It's really fast. Pause it and do it and then come back. I got, did you do it? Okay. I got 3.1781 divided by 1.7918. And then when you divide that out, just using your calculator, you get actually the same answer as your common log this time. All right? Okay, one last thing. Of course, we can't go without doing a word problem. These word problems are actually really, really simple because they give you the formulas. So if they give you the formulas, that's really the hardest part of a word problem. And I'm going to use, let's see, I didn't write it all out. The idea here is sound has an intensity measured, I believe, in watts, and the loudness of that sound is measured in decibels. And this is how we're going to show it. So the loudness of a certain intensity is shown by 10 times the log of the intensity divided by the initial intensity. And now this is actually, I think this is, I don't know if this is a general, yes, for a sound with intensity. So this is a sound, a formula for sound. So now what I want to know is, and I put this note to myself also, you're going to need this formula on your homework problems, on the word problems I give you in the homework. So this is the formula that you'll use. So make sure to write this down. All right, so the problem is asking, if the intensity of the sound is doubled, how many decibels did the sound increase? So what we're going to do is this. So we start out with our so if the loudness is doubled, the loudness of 2, we want to double that loudness, or the intensity, sorry. If the intensity is doubled, how much is the loudness increased? So if I want to know the increase, I want to know the difference between where we are now minus where we started. So I want to know the difference of 2 of the intensities minus the first intensity. So here's what we've got. We've got log, so we're going to put in, use the formula. So 10 log of 2 times the intensity divided by the original intensity minus 10 log of the intensity divided by the original intensity. Now, this is all complex and confusing. Let's simplify it. Let's make it easier. Because look, both of these, they're different, but they're both multiplied by 10. So let's take that 10 out. So 10 times log 2I minus log of I. All right, so if we have, this is 2 times something, remember we can pull it out and we can use that. Remember this, if it's multiplied, we can pull it out and add it. So let's make our lives a little bit easier. We could pull it all the way out and say this is log of 2 plus log of I minus log of the original intensity minus log of I minus log. So, but let's not, because watch this. If we do the log of 2 plus the log of what's left, you see what I did there? I took the 2 out because this is 2 times this, and this would be the same as 2 times the whole fraction. So I haven't done anything. This would be the same thing. So I'm going to take the 2 out because, and I could take it down further, but I don't really need to, because if you'll look, these two now are exactly the same, and this minus this makes that whole thing go away. So now I just have 10 log 2. So 10 log 2, I put that into my calculator. So you're going to have log 2, you could just plug it into your calculator. So if you're using your device calculator, it's going to be 2, and then log and get your answer and take that times 10. If you're using a scientific calculator, you just type it in just like that. 10 times log of 2 equals, and it should equal 3.01. And so your answer is 3.01 decibels. Ha-ha, easy sneezy. So the trick is going to be use those properties to your advantage in these problems. So when you need to be able to break it up further, break it up. But if you need to put it together so that something matches, go ahead and put it together. All right, here we go. Enjoy. See you soon.